first, let's talk about the very fundamental topic. Why are data and data management important? I have put together a few slides to cover the key points about this discussion. It's very obvious modern technologies and the systems are data-centric. Whatever we do is all surrounding the data, especially the business data. And data is a valuable asset to any organization. If we do data management, we can protect our data, make data usage effective and efficient. Also, we can increase the usability of our data. These are all very, very well known and very obvious. So I'm not going to talk too much about these bullets. Now let's see what data management entails. And I listed 3 categories of data management. The first category, data architecture. It includes database design and system integration. We will spend quite a lot of time talking about database design in the first several weeks. Also, we will be designing our project database. We will also go over system integration, and we can apply what we have learned about system integration to our project. The second category of data management is data engineering. And there are several items included in this category. Data pipelining. In old days, we called data pipelining ETL. Simply speaking, we will create some processes to move data from different data sources, perhaps to a central place. Along the way, we will do some transformation to make sure we prepare our data to be consumed by our applications, our solutions, such as data mining solutions or any other machine learning, artificial intelligence solution, right? So just to get the data prepared to be consumed by our applications and our users. The second item is database administration. Database administration is very comprehensive. It includes things like ongoing routine database work. We back up our data. We set up the databases. We do monitoring, and all of them are related to database administration. Out of many things for database administration, one thing is of particular interest. That's performance tuning. Just keep in mind, now when we develop an application, a solution, our probably number one priority is to make sure our solution, our application will perform well, right? If we have a solution, an application, which is not responsive, doesn't perform well, our users will turn away from it. So performance tuning is of particular interest and importance in industry. In many, many large environments, such as in Azure and AWS, in those very large public clouds, there are professionals doing nothing but performance tuning. The third category of data management is data mining. Many things belong to this category: reporting, analytics, machine learning, AI. We do database programming to analyze our data. We use tools to do data mining. So all of those belong to this category. We will be covering many of these things, these items in our course. Some of them we will go deeper. For some items, we will not go as deep, but I want to share some additional resources with the class so that if you are interested and you have time, you have bandwidth, you can dive deeper. Okay, so give me just a second. I want to copy the link. Oh, probably I need to copy the whole thing. It's best that I do this. Let's see. Okay, I put it in the message box. Can you try the link, see whether you can get to it? Okay, great. Keep in mind, those are great resources, okay? Not just for learning purposes. When you do industry work, these videos, these topics could be very helpful. I do industry work in addition to teaching, so I have spent quite some time putting together these videos. We have this data universal framework, and there are several layers in this framework. On top, we have visualization, applications, ORM, connectors. In the middle, we have SQL. At the bottom, we have databases, data processors, databases, and storage. It doesn't really matter what we do as long as we are a professional working with data, then we will be working within this framework. And it depends on our role, what profession we are in. If we are a data scientist or a data analyst, most likely we will be working at the top levels, visualization and applications. If we are a software development engineer, then if we just do application development, we will be working at the top levels. If we will be a system engineer or system developer, then we will most likely be working at lower levels. So we may develop a database management system or a component of the database management system. And I want to talk a little bit more about some of these layers. ORM and connectors. Nowadays, when we do application development, we do object-oriented development. But all applications are based on a database. In industry, most likely, we will be using a relational database. Then we will need a way so that we can map properties of our classes and objects to tables and columns in a relational database. So this is what this ORM does. is object relation mapping. Object relation mapping. Also, connectors are very, very important. Connectors will allow system integration. There are some very popular connectors such as JDBC, ODBC, Hadoop, Spark. Nowadays, in any organization, we all have many different application system solutions. When we do reporting and data analysis, we want to get a complete picture about the business. Therefore, we need to get data from a variety of solutions and applications. Then connectors can allow us to accomplish that, to do system integration. And SQL is widely used in industry everywhere. So SQL was invented, deployed to support relational databases. But today, SQL is being used as the common interface for NoSQL databases and the technologies as well. For example, if you use Databricks, you do data analysis, most likely you will be using SQL. As far as the bottom layers, so these are about the database management system. Databases will move data around throughout the database management system. Data processors are components like database engine, optimizer, and storage, obviously, our hard drive or our storage area network, right? In order to help us better understand this data universal framework, I have put together this example. So there are 4 sets of examples. We will focus on the relational, the first column, first set, and the third column, MongoDB without SQL. But we can easily extend these two columns to include the other 2 columns. The second column is about the cloud database, Cosmos DB in Azure. The very last column is MongoDB Atlas together with the SQL connector, such as Simba, ODBC, JDBC with SQL connector. We can implement a tool and this connector with the MongoDB database. Therefore, we can use SQL to manipulate data stored in our MongoDB database. So this framework is very interesting. Every point, every part of the framework is about data. And when we move data around within the framework, we do data management. Okay, so just take a look at this framework together with the examples. One thing I want to point out is this Lambda. This Lambda is very, very interesting. In old days, when we do data analysis, we do Hadoop, but Hadoop does batch processing. Today, Hadoop is still being used. You run a report, you do something in Hadoop. It may take a few hours, some time for you to get a response. But the industry and the businesses are demanding now. They want interactive action with the data, and they want up-to-date data. Therefore, we do streaming. So a lot of the streaming solutions are based on this Lambda architecture, Lambda. If you want to know more about Lambda, you can go to my YouTube channel, and there are many videos about this architecture and implementations of this Lambda architecture. Nowadays, everything is data-centric, and database is the foundation of modern solutions, modern software. If we can design the database well, then we can ensure the business requirements will be met. Also, we can get a great performance. And there are two types of databases which are widely used in industry and which are still relevant: relational and NoSQL. We will cover both in this course. So if you want to get more about the importance of database and general overview of the database development lifecycle, you can watch this video. Okay, so this is a very good, very popular video, not very long, about 15, 16 minutes. And this is also very interesting. And generative artificial intelligence is getting more and more attention. And we want to see how generative artificial intelligence and the data are related to one another. Look at this diagram. When we ask generative artificial intelligence a question, generative artificial intelligence will take our question or our prompt. Then it can also use a process, the retrieval augmented generation. It can use this process, RAG process, to get to our own data. So we ask a question, generative artificial intelligence will go through RAG using our own data to get more details about our question. Then our question, together with the additional context, additional details, will be sent to the large language model. It could be just a model as well. Then large language model will have enough details about our question. Therefore, it can return more accurate, more relevant responses to our question. Okay, so you look at this diagram, you can understand how data and data management will affect the operations of generative artificial intelligence. They really depend on one another. And this process, you look at this diagram, this entire process is also called grounding. We call this grounding. So generative AI grounding. The purpose is to get more relevant and more accurate responses to our Gen AI questions. Lastly, we want to see how data and data management are related to machine learning and AI projects, machine learning or AI solutions. On a machine learning or on an AI project, usually there are two parts of work. We have data engineering. We also have model operations. Model operations are ML or AI, right? So you look at this diagram. We need to first get data from a variety of our systems, a variety of data sources, to prepare the data to be consumed by the model. Along the way, in addition to getting data from original data sources, we may need to do some transformation. We may need to add some additional features which will be used by the model. So this part is data engineering, and this part is the foundation of any ML or AI project. Also, when the data is ready to be consumed by the model, we have ML AI engineers which will do experiments. They will train the model, run some testing, and they will focus on the function the model provides. And the function will be based on the features which were prepared in the underlying data engineering work. Once the solution is ready to be deployed in the production environment, we also need to monitor the performance. Performance is very important, right? So we need to make sure the model is running optimally. For model operations, model operations are based on a model, and we have data scientists which will develop and maintain models. But nowadays, the industry, a lot of commercially available models can be purchased. So there are thousands of models that we can select from in a large public cloud such as Azure and AWS. So if you look at a machine learning or AI project, and remember there are two parts of important work, right? Data engineering and model operations, and we have several roles or several types of professionals working on such a project. We have data engineer. So a data engineer will be preparing the data to be consumed by the model. In industry, very often, some junior machine learning and AI engineers also do data engineering work. Then we have machine learning, AI engineers, which will run experiments, also optimize the running of the AI ML solution. A data scientist will be doing model development and model maintenance. Additionally, we may have some project management resources. And this can clearly demonstrate how important data and the data management are to a machine learning and AI project. By considering what we just went over, I think it's very obvious data and data management are very, very important.